All right, 10.3. I'm finally recording your notes. Um, you're probably going to always be at the end, more in the middle of the day. It takes a little bit more brain power for me to do yours, and I usually have to actually go through them, unlike, say, Algebra 1, where I can just do it. On example 2, just to give you a heads up, we're going to go over that with a separate video. That one's kind of a weird special case, and I'm going to need more room to work. So I'm going to record these notes. I'm not going to do number 2, and then I'll re-record number 2, or actually record number 2 and then post it. Okay. Leah, update on the Oreo situation. So I'm not going to lie to you. I ate most of them that day that I recorded, and then I brought them home, and I told Tony that I had Oreos, and then he left for work, and I was hungry, so then I ate the remainder of the Oreos. So your Oreos caused a little bit of a tiff in our relationship because we fought over Oreos for a hot second. No worries, I got more, but I hid them from him. So we'll see how long it takes for him to find them in the cupboard. Oh, and if I eat them beforehand. And since there's no Planet Fitness, this is going to end really well. And hashtag there might be a wedding season because we don't know if there's going to be a wedding. So anyway, updates of my life. I know you all wanted to really hear about that. Okay. So let's do this warm-up. This warm-up is u-Substitution. The only difference between what we're doing here and what we did in 10.1 is we're doing definite integrals. So we have some numbers now to calculate, and there's kind of a weird little situation you have to do. So it's not too bad, it's just weird. So in this situation, we want the u to be the sine of 2x because it's inside of this 5. It doesn't look like it, but it is. And then you're going to take du, and you're going to derive it. And then you have to do the chain rule. So you derive the sine, which is cosine of 2x. And then the derivative of the 2x is just 2. So I'm going to write it here. And then we got to solve for dx, which would give us 1 over 2 cosine of 2x du. And then we plug it into here. I'm definitely going to run out of some room, so I'm probably going to skip some steps here. Sorry. So the cosine of 2x and the cosine of 2x are going to cancel out. And then I can kick that. Oops, I always do this. Once a video. You don't know that, but at least once every video I make, I click that. All right, so it's 1 over 2, and then that's gone with this, and you're left with u to the 5th power du. So I just skipped some massive steps there. You don't have to do it. I'm sorry. Don't hate me. If you integrate that, that's going to get you 1/6 to the u to the 6th power, technically plus c, and then you'd plug in the u, and you get 1/12 sine to the 6th power of 2x plus c. And that is right here. So our answer is A. All right, so what we're doing different today is, again, this is going to be a definite integral, but you got to do some weird substitution within the restraints, like, for example, number 1 and 0 and 1. It's called change of variables or change of terms. I'm not going to write it out because I think it's going to make it more complicated if I do this. So we're just going to dive right into number 1. I have a feeling I'm going to make my pen a little bit thinner because there's going to be a little bit of writing here. Okay, so treat this problem just like we have been. We're going to find the u, okay, and the u in the situation is going to be the x squared plus 1. And the reason it's the x squared 1, if you derive this, you get 2x dx, and that x will cancel with that x. All right, so then we solve for dx, and we get 1 over 2x du. So we just divided this over. Do not write the restraints or the constraints down, just write this for right now. So we have x times u to the 3rd power, and then the dx is going to be taken away with the 1 over 2x du. And we know the x's will cancel, leaving us with 1/2 on the outside, and then u to the 3rd power du. Now there's different ways you can go about it, and probably different teachers teach it different ways. I'm going to follow the way that flipped calculus site, and what probably most people do, but just know there are different ways to do this. So if you find something else on the internet, you can use that method. That's okay. So basically what it's saying is there's a quicker, easier way to do this. We could put the x squared plus 1 in and then calculate it, and it's really not that bad, but there's an easier way, and we're going to go with what's easier. So you got to kind of change the restraints or the constraints, whatever you want to say it. Okay, so what you're going to do is you're going to say, okay, the lowest value I have is 0. If I plug it into u right here, what do I get? Well, 1 squared is 1 plus 1, so that equals 2. So now I'm going to put 2 on the bottom, basically because you're deriving with respect to u, and we haven't changed back to x. And then you have x equals 1. If you plug that into the u, you get 1 squared Oops, I messed up here. Ooh. Back up, back up, back up, back up, pause. If you plug 0 into here, you get 0, which is 1. So this isn't 2, this is 1. I'm just going to do the undo button. Just give me a second. We're just going to undo this. What was I thinking? Okay, so try again. X equals 0. Plug it into the u, and you get 0 plus 1, which is 1. And if you plug in the 1 into the u, you get 2, because I already calculated it. So 1 plus 1 is 2. So you get 1 on the bottom and 2 on the top. Okay, so then we're going to integrate the u squared. And we know we add 1, and so I'll have 1/2 times 1/4 u to the 4th, and we're going from 1 to 2. And we're not going to have to plug that u back in, but I am going to simplify this real quick. So you have 1/8 u to the 4th, and then 1 and 2. And the reason you don't have to plug this x back in is because we changed these values right here with respect to u. So it's kind of just freeing up some work. So we plug the 2 in. 2 to the 4th is 16. So we have 1/8 times 16 minus, and plug the 1 into here and you get 4, so it's just 1/8. So that ends up being, keep it this way, 16 over 8 minus 1 over 8, which is 15 over 8, and that is our answer, right? Now, the real reason I didn't simplify anything is I just knew this had a 1/8, so I just went ahead and keep it with a fraction. Number 2, it's a special case, so we're doing it later, separate video, okay? And we're going to move right down to number 3. Okay, hopefully you're starting to recognize when and what is the u in u-substitution, and in this situation, the sign of x is the u. So we're going to go ahead and derive that. And the derivative sign of x is cosine of x dx. And then you're going to do the lovely thing of where you saw for dx, and that's 1 over cosine of x du. Now you can simplify that, but that's not going to help us here. Okay, so integral, not writing these yet, cosine of x times u to the 1/2. I'm going to go ahead and write to the 1/2 because that's what this is. And then 1 over cosine of x du. And these cancel, leaving you with u to the 1/2 du. All right, so now we have to work with our lower and upper bounds. So x equals 0 is the lower. If you plug in 0 into here, so sine of 0, if you look at your unit circle, that actually happens to equal 0 because unit circle, this is 0, y value is sine, so 0. The other one's pi over 2 that we're going to plug in. And that gives you u equals sine of pi over 2. If you use your unit circle or you think here, pi over 2 is right there, so that equals 1. So instead of having 0 and pi over 2, we're going to have 0 and 1, which is nice because that means you already worked with the trig functions and you don't have to worry about them. If you integrate 1/2, you're going to add the 1, which gets you 3/2. So doing the reciprocal is 2/2. And this is what you get. Okay? So what's really great about this too is that the 0 is 0. If you plug in the 1, it becomes 1 cubed, which is 1, and the square root of 1 is 1, so it's 1, so it's 2/3 minus 0, so your answer is 2/3. So it's not too bad, okay? I think I only have one more example for you, and then everything on the back side of those notes, the even and odd stuff, we're just not going to do. I'm just not going to make life more difficult than it has to be. Okay, so I want to see how far you can go on this one on your own, and then we'll go from there. So go ahead and try the problem, see what you can do, start the video up when you either get stuck or you're done, all right? So pause the video now. All right, now that you've restarted the video, let's go ahead and do this. Hopefully you thought to yourself, x squared plus 4 is on the bottom, it's in a reciprocal function, that's what I want to use as my u, because if you did, you're right, okay? And because if you square root, or take the derivative of this, you get 2x dx, and that would get rid of this x right here. And then you would solve for dx, and it gives you 1 over 2x du. So we have, not putting the boundaries, x over u times, and the dx is 1 over 2x du, which gets rid of the x's. It's going to kick out that 1/2, and we're going to keep it as 1 over u, and hopefully you catch on y soon. So we're going to plug the lower and upper boundaries in. So if we plug in 0 into here, you just get 4. And if you plug in e, this one's pretty simple, you get e squared plus 4. Okay, so our boundary is oddly enough 4 and e squared plus 4. Okay, now if you think of this is really u to the negative first power, and if you add 1, that's 0, and then it's gone. So you can't do that. Hopefully you recognize that this is the natural log. So we have 1/2 natural log of u from 4 and e squared plus 4. And all you do is plug it in and that's your answer. Simple as that. So we plug in the, I'm going to keep, by the way, keep that 1/2 with each one just because I can. Plug in that e squared plus 4. Now typically you could cancel these two if it wasn't added the 4. The 4 kind of messes that all up. And then you get this, and that's your answer. And that's it. And we're not doing any of this stuff because I just don't want to. Just don't want to. Don't care. All right. I will post that other video, but that's a good start for today. Best of luck. Let me know if you have questions.